Sixth grade, Unit 1, Lesson 1, Tiling the Plane. Number 1. Which square, large, medium, or small, covers more of the plane? Explain your reasoning. For the small squares, they cover 10 small squares. The medium squares cover a total of 40 small squares, and the large squares cover a total of 45 small squares. The large squares cover the most area. Number 2. Draw 3 different quadrilaterals, each with an area of 12 square units. In blue, I've drawn a quadrilateral with an area of 12 square units, and its dimensions are 1 by 12. In green, the dimensions are 2 by 6. And the third quadrilateral's dimensions are 3 by 4. Number 3. Use copies of the rectangle to show how a rectangle could A. Tile the plane, B. Not tile the plane. Let's go ahead and start with A. Tile the plane. My colors didn't match up well, but you can get the idea. When you tile the plane, you tile the entire plane. You don't leave any spaces or any gaps. And B. Not tile the plane. So when you don't tile the plane, you leave gaps and you leave spaces. This is just one example. You can leave your gaps and spaces wherever you like. Number 4. The area of this shape is 24 square units. Which of these statements is true about the area? Select all that apply. A does not apply. This is more like finding the perimeter, not the area. B does apply. It takes 24 grid squares to cover the shape without gaps and overlaps. That is the area. C does not apply. Even though 6 times 4 does equal 24, you would need to multiply the base times the height of quadrilaterals to find the area. And in example C, they're multiplying 2 bases times one another. Example D is correct. The area can be found by counting the grid squares inside the shape. There are 24 grid squares inside the shape. E applies because the area can be found by adding 4 times 3 and 6 times 2. It's kind of like what I was talking about in example C, multiplying the base times the height of quadrilaterals. I've identified 2 quadrilaterals within this shape, one with dimensions of 4 times 3 and the second one with dimensions of 2 times 6. 4 times 3 is 12 and 2 times 6 is 12. 12 plus 12 is 24 units. 5. Here are 2 copies of the same figure. Show 2 different ways for finding the area of the shaded region. All angles are right angles. The area of the large rectangle is 10 times 6, or 60 units. The area of the blue shaded section is 60 minus 5 minus 3 minus 10, or 42 units. Now I've broken down the shape into 3 quadrilaterals. The quadrilateral on the left has the dimensions of 3 times 5. The quadrilateral in the middle has dimensions of 5 times 3, and the quadrilateral on the right-hand side has the dimensions of 2 times 6. The area of the quadrilateral on the left is 15, the area of the quadrilateral in the middle is also 15, and the area of the quadrilateral on the right is 12. 15 plus 15 plus 12 equals 42. Just like the shaded blue area in the shape on the left, the area of this shape is also 42. Number 6. Which shape has a larger area? A rectangle that is 7 inches by 3/4 of an inch, or a square with side length of 2.5 inches? Show your reasoning. 7 inches can be represented as 7/1, and 7/1 times 3/4 inches equals 21/4 or 5 1/4 inches. 2.5 times 2.5 is the same as 5/2 times 5/2, which equals 25/4 or 6 1/4. The square has the larger area because 6 1/4 is greater than 5 1/4. Unit 1, Lesson 2, Finding Area by Decomposing and Rearranging. Number 1. The diagonal of a rectangle is shown. A. Decompose the rectangle along the diagonal and recompose the two pieces to make a different shape. Any of these shapes would work. B. How does the area of this new shape compare to the area of the original rectangle? Explain how you know. The new shape has the same amount of area as the original shape because they are both made from the same two pieces. Number 2. The area of the square is 1 square unit. Two small triangles can be put together to make a square or to make a medium triangle. So the square is 1 by 1, which is 1 square unit. The small triangle is 1/2 a unit squared, and the medium triangle is 1 unit squared. Which figure also has an area of 1.5 square units? 3 small triangles, 3 small triangles, a medium triangle and a small triangle, 2 small triangles, and 1 square. A totals 1.5 square units, so does B, so does C, but not D. D is a total of 2 square units. Number 3. Priya decomposed a square into 16 smaller equal-sized squares and then cut out 4 of the small squares and attached them around the outside of the original square to make a new figure. How does the area of her new figure compare with that of the original square? B. The two figures have the same area. Number 4. The area of a rectangular playground is 78 square meters. If the length of the playground is 13 meters, what is the width? Well, we know that the area is 78 meters, and we know that the length is 13 meters. But we don't know the width. We do know that the formula of the area of a rectangle is length times width. And since we know the length, we can plug in length as 13. The area equals 13 times the width. And since we know the area is 78, 78 equals 13 times the width. What number times 13 equals 78? 6. Or 78 divided by 13 equals 6. So the width is 6. The length is 13 and the width is 6. Inside this rectangle, there would be 78 meter squares. Number 5. A student said, "We can't find the area of the shaded region because the shape has many different measurements instead of just a length and a width that we could multiply." Explain why the student's statement about the area is incorrect. They can find the area by multiplying 60 by 30, then subtracting the empty square units I have identified in red. Unit 1, Lesson 3, Reasoning to Find Area. Number 1. Find the area of each shaded region. Show your reasoning. A. I've broken this shape down into 3 different shapes. The rectangle on the left is 2 units wide by 5 units tall. The rectangle in the middle is 2 units wide by 4 units tall. And the square on the right side is 2 units wide by 2 units tall. 10 plus 8 plus 4. The area of shape A is 22 square units. B. This shape can be looked at as a square with a side length of 6 and two smaller squares that were removed. So 6 times 6 minus 2 times 2 minus 2 times 2 equals 36 minus 4 minus 4. The area of B is 28 square units. C. Draw a line down the middle of this symmetrical shape and you'll notice two identical shapes. If you stack this shape on the right on top of the shape on the left, you'll have a rectangle. The dimensions would be 6 units for the height and 3 units for the width. The area for C is 18 square units. Number 2. Find the area of each shaded region. Show or explain your reasoning. A. This shape is almost a square. Imagine it is a square that's 6 by 6 and it's missing a section that's 2 by 4. The area of the shaded region is 28 square centimeters. B. This shape is a rectangle that's 8 by 5, and cut out of the middle of it is a rectangle that's 2 by 3. 8 times 5 minus 2 times 3. The area of the shaded region is 34 square centimeters. C. Here we have a rectangle with dimensions 15 by 10 and a smaller rectangle cut out of the inside with dimensions 6 by 9. The area of the shaded region is 96 square centimeters. D. When you decompose this symmetrical shape, you can form a rectangle that has dimensions of 8 by 5. The area of the shaded region is 40 square centimeters. Number 3. Two plots of land have very different shapes. Noah said that both plots of land have the same area. Do you agree with Noah? Explain your reasoning. Yes, I agree with Noah. After decomposing plot B, I was able to compose plot B into the same exact shape as plot A. Number 4. A homeowner is deciding on the size of tiles to use to fully tile a rectangular wall in her bathroom that is 80 inches by 40 inches. The tiles are squares and come in 3 side lengths, 8 inches, 4 inches, and 2 inches. State if you agree with each statement about the tiles. Explain your reasoning. I do not agree with A, because the smaller the tiles, the more tiles will be needed. B. Regardless of the size she chooses, the area of the wall that is being tiled is the same. Yes, I agree with this statement because the size of the wall will not change. She will need 2 2-inch tiles to cover the same area as one 4-inch tile? No, because 4 2-inch tiles fit inside a 4-inch tile. She will need 4 4-inch tiles to cover the same area as one 8-inch tile. That's true because 4 4-inch tiles fit inside one 8-inch tile. If she chooses the 8-inch tiles, she will need a quarter as many tiles as she would with 2-inch tiles. That's not true, because 16 2-inch squares fit inside one 8-inch square. She would need 1/16 as many 8-inch squares as she would 2-inch squares. Unit 1, Lesson 4, Parallelograms. Number 1, select all of the parallelograms. For each figure that is not selected, explain how you know it is not a parallelogram. Figure B is a parallelogram. Opposite sides are parallel and opposite sides are the same length. Figure C is also a parallelogram, with opposite sides being the same length and opposite sides being parallel. Figure A is not a parallelogram, it's a trapezoid. One set of opposite side lengths are not parallel, and the other set of opposite side lengths are not the same length. Figure D is a pentagon. and figure E is a right triangle. Number 2A. Decompose and rearrange this parallelogram to make a rectangle. B. What is the area of the parallelogram? Explain your reasoning. Number 3. Find the area of the parallelogram. The area is base times height. The base is 10 centimeters. The height is 3 centimeters. The area would be 10 times 3. The area is 30 square centimeters. Number 4. Explain why this quadrilateral is not a parallelogram. These opposite sides highlighted in red are not parallel and they're not the same length. These opposite sides highlighted in yellow are parallel, however, they're not the same length. This quadrilateral is not a parallelogram because its opposite sides highlighted in red are not the same length and not parallel, and the opposite sides highlighted in yellow are not the same length. To be a parallelogram, the opposite sides would have to be parallel and be the same length. Number 5. Find the area of each shape. Show your reasoning. The area of the shape is 2 units by 6 units, which is 12 square units. We've turned the one shape into 2 shapes, and the areas of the 2 shapes are 3 by 5 and 1 by 4. 3 times 5 is 15, 1 times 4 is 4, 15 plus 4 is 19. The combined area of the original shape is 19 square units. Here's a closer look at the 19 square units. 15 square units in the larger shape and 4 square units in the smaller shape. Number 6. Find the areas of the rectangles with the following side lengths. A. 5 inches and 1/3 inches. 5/1 times 1/3 equals 5/3 square inches. B. 5 inches and 4/3 inches. 5/1 times 4/3 equals 20/3 square inches. C. 5/2 inches and 4/3 inches. 5/2 times 4/3 equals 20/6, which is the same as 10/3. 10/3 square inches. D. 7/6 inches and 6/7 inches. 7/6 times 6/7 equals 42/42, which is the same as 1. The area is 1 square inch. Unit 1, Lesson 5, Bases and Heights of Parallelograms. Number 1, select all parallelograms that have a correct height labeled for the given base. In relation to the base, the height's going to be at a 90-degree angle. Figure A. They've labeled height and base, and you'll notice that the height is at a 90-degree angle compared to the base. Figure B. They've labeled the height and the base, but you'll notice that the height is not at a 90-degree angle compared to the base. If the height were located here in purple, it would be at a 90-degree angle. Figure C. They've labeled the base and the height, and you'll notice that the height is at a 90-degree angle compared to the base. Figure D. They've labeled the height and the base, and the height is at a 90-degree angle compared to the base. For figures A, C, and D, I'll highlight the 90-degree angle in yellow. And for figure B, I'll highlight the angles in orange, and you'll see that one angle is greater than 90 degrees and another angle is less than 90 degrees. In purple, I've added the correct line for height, which you can see in comparison to the base is 90 degrees. Number 2. The side labeled B has been chosen as the base for this parallelogram. Draw a segment showing the height corresponding to that base. We have a lot of choices as to where we can draw a segment that shows the height corresponding to that base. Here's a few segments that would represent height corresponding to B. 3. Find the area of each parallelogram. To find the area, you multiply base times height. Here we have a base of 4 and a height of 2, so 4 times 2 is 8. The area would be 8 square units. B. We can rearrange figure B so it looks a lot like figure A. Simply rearranging it can help us tell that it has a height of 2 and a base of 5. So the area would be 10 square units. For figure B, you can find the area without rearranging it. Just find the height, which would be at a 90-degree angle compared to the base. And again, we have the base of 5 and a height of 2, and 5 times 2 is 10, so the area would be 10 square units. Figure C. We can also rearrange figure C so it looks a lot like A. Now we can see that its base is 4 and its height is 2. The area would be 8 square units. We don't have to rearrange figure C. We can just locate its base and its height. Its height will be at a 90-degree angle in relation to its base. Here we can see it has a height of 2 and a base of 4. 4 times 2 equals 8. Its area would be 8 square units. Number 4. If the side that is 6 units long is the base of this parallelogram, what is its corresponding height? I've highlighted its base in blue, and the corresponding height is going to be at a 90-degree angle in comparison to its base. Since this makes a 90-degree angle corresponding to the base, I would select C, 4 units. Number 5. Find the area of each parallelogram. A. The base is 9 centimeters and the height is 4 centimeters. So 9 times 4 is 36. The area would be 36 square centimeters. B. The base is 5 centimeters, and if you notice, the 4 centimeter measurement creates a 90-degree angle with the base. So the height is 4 centimeters. And the base times the height, or 5 times 4, equals 20 square centimeters. C. They've identified the base as B. The height would be at a 90-degree angle compared to B. H is the height and B is the base. Base times height equals the area. The area equals B times H, or BH square units. Number 6. Do you agree with each of these statements? Explain your reasoning. A. A parallelogram has 6 sides. No, because a parallelogram is a quadrilateral that has 4 sides. B. Opposite sides of a parallelogram are parallel. Yes, because opposite angles are equal, and if opposite angles are equal, the opposite sides will be parallel. C. A parallelogram can have one pair or two pairs of parallel sides. No, parallelograms have two pairs of parallel sides. D. All sides of a parallelogram have the same length. No, because sometimes all sides of a parallelogram are the same length. E. All angles of a parallelogram have the same measure. No, because opposite angles are equal, but it is possible to have angles that are not opposite to be different measure. Number 7. A square with an area of 1 square meter is decomposed into 9 identical small squares. Each small square is decomposed into 2 identical triangles. A. What is the area in square meters of 6 triangles? If you get stuck, draw a diagram. I'll draw a diagram and I'll start with 1 square meter. Then I'll divide it equally into 9 squares. Each square is 1/9 of the meter. Next, I need to cut those squares into triangles, or in half, which would make each triangle 1/18 of a meter. In other words, there's 18 altogether. If I take 6 out of the 18, I have 6/18, or 1/3 of a meter. The area of 6 triangles is 1/3 square meters. B. How many triangles are needed to compose a region that is 1.5 square meters? 1.5 square meters would be 1.5 the amount of the meter square. And since the meter square held 18 triangles, and 9 is half of 18, 18 plus 9 would be 27. So 1.5 square meters would hold 27 of these triangles. Unit 1, Lesson 6, Area of Parallelograms. Number 1. Which 3 of these parallelograms have the same area as each other? The dimensions for figure A are 3 by 5. The dimensions for figure B are 3 by 5. The dimensions of figure C are 4 by 4. And the dimensions for figure D are 3 by 5. Parallelograms A, B, and D all have the same area as each other. And 3 times 5 is 15, so their area would be 15 square units. Number 2. Which of the following pairs of base and heights produce the greatest area? All measurements are in centimeters. For figure A, base times height equals 14 square centimeters. Figure B, base times height equals 16 square centimeters. Figure C, base times height equals 13 5/10 square centimeters. And figure D, base times height equals 14 square centimeters. Figure B has the greatest area, 16 square centimeters. Number 3. Here are the areas of 3 parallelograms. Use them to find the missing length, labeled with a question mark, on each parallelogram. Figure A has the area of 10 square units, the base is 5, and the height is unknown. 10 divided by 5 equals 2. Or 5 times 2 equals 10. The area for figure B is 21 square units. The height is 7 and the base is missing. 21 divided by 7 is 3, or 7 times 3 is 21. The measurement for the missing base is 3 units. The area for figure C is 25 square units. The height is 5 and the base is unknown. 25 divided by 5 is 5, or 5 times 5 is 25. The measurement for the missing base is 5 units. Number 4. The Dockland building in Hamburg, Germany is shaped like a parallelogram. If the length of the building is 86 meters and its height is 55 meters, what is the area of this face of the building? 86 meters represents the length in yellow, and 55 meters represents the height in blue. 86 meters times 55 meters equals 4,730 square meters. The area of the face of the building is 4,730 square meters. Number 5. Select all segments that could represent a corresponding height if the side M is the base. I highlighted side M in red. It represents the base. Line segments E, F, J, and K are all at a 90-degree angle in comparison to side M. So if side M is the base, E, F, J, and K all represent the height. Number 6. Find the area of the shaded region. All measurements are in centimeters. Show your reasoning. The shaded region is on the inside of an even larger rectangle. The shape of the shaded region is also a rectangle, and it's sitting at an angle which forms 4 small triangles that are not shaded. The dimensions for this small triangle are 2 by 6. This larger triangle has dimensions 4 by 12. Here's another smaller triangle that's also 2 by 6, and another larger triangle with dimensions 4 by 12. We can use these dimensions to help us figure out the height and the base of the larger rectangle. 12 plus 2, or 14 for the base, and 6 plus 4, or 10 for the height. The large rectangle's area is 14 times 10, or 140 square centimeters. Combine the 2 small triangles, 2 by 6, to form a rectangle with an area of 12 square centimeters. Combine the 2 large triangles, 4 by 12, to form a rectangle with an area of 48 square centimeters. Remove 12 square centimeters and 48 square centimeters from 140 square centimeters to find the area of the shaded region. The area of the shaded region is 80 square centimeters. Unit 1, Lesson 7, From Parallelograms to Triangles. Number 1. To decompose a quadrilateral into 2 identical shapes, Claire drew a dashed line as shown in the diagram. A. She said that the 2 resulting shapes have the same area. Do you agree? Explain your reasoning. Here's a closer look at the dashed line that Claire drew. The result is 2 shapes, one on the left, one on the right. The shape on the left is a triangle, which is half of this square. The dimensions of the square would be 4 by 4. That would give the area of the square 16 square units. The shaded region is a triangle, which is exactly half the area as the square. The area of the triangle would be 8 square units. And we can look at the rectangle on the right and see that its dimensions are 2 by 4, and 2 times 4 is 8. So the area of the rectangle is also 8 square units. I'm going to decompose the triangle and then rearrange it so that you can see that it has the same area as the rectangle on the right. Look carefully and you'll notice that this triangle consists of 4 half-unit squares and 6 one-unit squares. I'm going to rearrange the half units to make 1-unit squares. Now that I combined the half-unit squares, we have all 1-unit squares. Now I can rearrange these unit squares and stack them on top of each other to make a rectangle that has the dimensions 2 by 4, just like the rectangle on the right. She was correct. They each have an area of 8 square units. Number 2. Triangle R is a right triangle. Can we use 2 copies of triangle R to compose a parallelogram that is not a square? If so, explain how or sketch a solution. If not, explain why not. The answer is yes. Here's 2 examples of how I use 2 copies of triangle R to compose a parallelogram that is not a square. Number 3. 2 copies of this triangle are used to compose a parallelogram. Which parallelogram cannot be a result of the composition? If you get stuck, consider using tracing paper. I used a line to separate the copies of the 2 triangles in figures A, B, and D. Figure C didn't work. It's composed of 2 triangles that are a different shape than the triangle on the left. Number 4A. On the grid, draw at least 3 different quadrilaterals that can each be decomposed into 2 identical triangles with a single cut. Show the cut line. 1 or more of the quadrilaterals should have non-right angles. I've come up with 4 examples. The first 3 don't have right angles and the square does have right angles. I can decompose these into identical triangles with a single cut line. B. Identify the type of each quadrilateral. The first 3 quadrilaterals are parallelograms and the 4th one is a square. Number 5. A. A parallelogram has a base of 9 units and a corresponding height of 2/3 units. What is its area? To figure out the area, we're just going to multiply the base times the height, or 9 times 2/3. So we can just multiply 9 times 2/3, but I have a different way to show you that I think you might find interesting. Using a piece of graph paper, I've drawn out 9 square units, and each of the 9 square units are divided into thirds. Since the height of the parallelogram in the problem is only 2/3 tall, I colored in 2/3 of each of these units. Rather than just having 9 units that are only 2/3 the way filled, I'm going to start decomposing and rearranging to fill up as many units as I can. I've decomposed it and rearranged it so that now I have 6 full units. 9 times 2/3 equals 6. The area of a parallelogram that has a base of 9 units and a height of 2/3 units is 6 square units. B. A parallelogram has a base of 9 units and an area of 12 units. What is the corresponding height for that base? We know that base times height equals area, but they haven't given us the height. So we have base times unknown equals the area, or 9 times the unknown number equals 12. To figure out what number we multiply times 9 to get 12 is the same thing as how many times does 9 fit into 12, or how many times does 9 go into 12. And to figure that out, we need to divide 12 by 9. And 12 divided by 9 is 4/3, which is the same as 1 and 1/3. So the height of this parallelogram is 4/3 or 1 1/3 units. C. A parallelogram has an area of 7 square units. If the height that corresponds to a base is 1/4 unit, what is the base? This illustration represents a parallelogram that has an area of 7 units and a base of 1/4 unit. The height is unknown. Again, we know that base times height equals the area. They provided us with the base and the area. 1/4 times height equals 7 square units. We need to figure out what number times 1/4 equals 7. Or how many times does 1/4 go into 7? 7 divided by 1/4 equals 28. So 1/4 times 28 equals 7. We know that the height is 28 units. Number 6. Select all segments that could represent a corresponding height if side n is the base. In order to find the height, we need to find side lengths that are at a 90-degree angle compared to side n. I've drawn side n in red, and both segments G and H are at 90-degree angles to side n and represent the height when side n is base. Unit 1, Lesson 8, Area of Triangles. Number 1. To find the area of this right triangle, Diego and Jada used different strategies. Diego drew a line through the midpoints of the two longer sides, which decomposes the triangle into a trapezoid and a smaller triangle. He then rearranged the two shapes into a parallelogram. A. Explain how Diego might use his parallelogram to find the area of the triangle. Since Diego's parallelogram is made out of the same parts as the triangle, he can simply multiply the base times the height. 3 times 4 equals 12. The area of Diego's parallelogram is 12 square feet. And since the parallelogram is made out of the same parts as the triangle, the area of the triangle would also be 12 square feet. Jada made a copy of the triangle, rotated it, and lined it up against one side of the original triangle so that the two triangles make a parallelogram. B. Explain how Jada might use her parallelogram to find the area of the triangle. Unlike Diego, Jada didn't make her parallelogram out of the same parts as the triangle. Since Jada used the original triangle and a copy of the original triangle, the area of her parallelogram is going to be twice the size of the area of the triangle. So when we multiply the base times the height, 3 times 8, we'll get 24. But since this area is twice the size of the area of the original triangle, we'll have to divide that by 2. 24 divided by 2 is 12. The area of the original triangle is 12 square feet. Number 2. Find the area of the triangle. Explain or show your reasoning. A. I decided to decompose this triangle by removing a section and rearranging it so it becomes a rectangle. Now that I have a rectangle, I can easily see that the base is 6 and the height is 2. 6 times 2 is 12. The area of this rectangle is 12 square units, and the area of the triangle is 12 square units, because the rectangle was made out of the same parts as the triangle. B. I'm going to decompose this triangle and rearrange it so it becomes a parallelogram. I need to make a horizontal cut halfway between the base and the opposite vertex. And the distance between the base and the opposite vertex is 3. So I'll have to make a horizontal cut 1.5 units above the base. And then rearrange it into the shape of a parallelogram. The base of the parallelogram is 4 and the height is 1 5/10. I need to multiply the base times the height to get the area. So 4 times 1 5/10 equals 6. The area of the parallelogram and of the triangle is 6 square units. Number 3. Which of the 3 triangles has the greatest area? Show your reasoning. If you get stuck, Use what you know about the area of parallelograms to help you. I'm going to go ahead and use what I know about parallelograms to help me. So the first thing that I need to do is turn these triangles into parallelograms, either by decomposing and then rearranging into the shape of a rectangle, or copying the shape of the triangle and attaching it to the existing triangle to make a rectangle or a parallelogram. Now it's pretty easy for me to find the base and the height of the rectangle and parallelograms. But remember, the area of the rectangle and parallelograms are twice the area of the original triangles. They all have a base of 5 units and a height of 4 units, which is an area of 20 square units. So all the triangles would have an area of 10 square units. It turns out that neither of the 3 triangles has the greatest area. They all have an equal area of 10 square units. Number 4. Draw an identical copy of each triangle such that the 2 copies together form a parallelogram. If you get stuck, consider using tracing paper. I've drawn identical copies of each triangle and I've joined them together to form parallelograms. Number 5. A parallelogram has a base of 3 5/10 units and a corresponding height of 2 units. What is its area? Again, to find the area, we need to multiply the base times the height. 3 5/10 times 2 will equal the area. 3 5/10 times 2 is 7. So the area would be 7 square units. B. A parallelogram has a base of 3 units and an area of 1 8/10 square units. What is the corresponding height for that base? They've told us that the base is 3 units and that the area is 1 8/10 square units, but they haven't told us the height, so we need to figure out the height. Base times height equals area. The base is 3, the height is unknown, and the area is 1 8/10 square units. So we need to find out what number times 3, or 3 times what number, equals 1 8/10. And we can do that by dividing. 1 8/10 divided by 3 will tell us the height. 1 8/10 divided by 3 is 6/10. So the height would be 6/10 of a unit. C. A parallelogram has an area of 20 4/10 square units. If the height that corresponds to a base is 4 units, what is the base? Again, we know that the base times the height equals the area. The base is unknown, but we do know that the height is 4 and the area is 20 4/10 square units. What number times 4 equals 20 4/10? We can figure that out by dividing 20 4/10 by 4. 20 4/10 divided by 4 is 5 1/10. The base is 5 1/10 of a unit. Unit 1, Lesson 9. Formula for the area of a triangle. Number 1. Select all drawings in which a corresponding height, h, for a given base, b, is correctly identified. So I'm looking for the height, h, that's at a right angle compared to the base, b. Triangles A, B, D, and F all have height h at a right angle compared to base b. Number 2. For each triangle, a base and its corresponding height are labeled. A. Find the area of each triangle. To find the area of these triangles, we're going to use the formula half of the base times height equals the area. For triangle A, the base is 4 and the height is 6, so half of 4 times 6. 4 times 6 is 24, and half of 24 is 12. The area of triangle A is 12 square units. The base for triangle B is 8, and the height is 4. Half of base times height, or half of 8 times 4. And 8 times 4 is 32. Half of 32 is 16, so the area for triangle B is 16 square units. The base for triangle C is 6, and the height for triangle C is 4. So half of 6 times 4, or half of 24, is 12. The area of triangle C is 12 square units. B. How is the area related to the base and its corresponding height? The area of each triangle is half of the base times the height. You can write that as half of the base times the height, or base times height divided by 2. Number 3. Here is a right triangle. Name a corresponding height for each base. A. If the base were side D, then the corresponding height would be side G, because side G is at a 90-degree angle compared to side D. B. If the base were side E, then the corresponding height would be side F, because side F is at a 90-degree angle compared to side E. C. If side F were the base, then the corresponding height would be side E, because side E is at a 90-degree angle to side F. Number 4. Find the area of the shaded triangle. Show your reasoning. The shaded area is the shape of a triangle, so we're going to use the formula 1/2 of base times height, and in this case it would be 1/2 of 6 times 6. And 6 times 6 is 36. Half of 36 is 18, so the area of this shaded triangle would be 18 square units. Look at it this way. I'm going to decompose this square. On the top we have a rectangle that's 6 by 2, and on the bottom we have a larger rectangle that's 6 by 4. The smaller rectangle on top has an area of 12 square units, and the larger rectangle on the bottom has an area of 24 square units. For the top rectangle we multiplied 6 times 2 to get 12. For the bottom rectangle we multiplied 6 times 4 to get 24. Each of the rectangles consists of 2 triangles, and the area of each of those triangles would be exactly half of the area of the rectangle. The areas of the triangles in the top rectangle are 6 square units each, and the areas of the triangles in the bottom rectangle are 12 square units each. The entire shaded region would be 6 square units plus 12 square units, which would equal 18 square units. The area of the white region would also be 18 square units. 18 plus 18 is 36 square units, which is the area of the entire square. 6 times 6 would be 36 square units. Both the shaded region and the white region cover half the area of the square. The area of the square is 36 square units, so the shaded region would be 18 square units, because 18 square units is half of 36 square units. Number 5. Andre drew a line connecting 2 opposite corners of a parallelogram. Select all true statements about the triangles created by the line Andre drew. A. Each triangle has 2 sides that are 3 units long. That's not true. They each have 1 side that's 3 units long, but they don't have 2 sides that are 3 units long. B. Each triangle has a side that is the same length as the diagonal line. True. C. Each triangle has 1 side that is 3 units long. That's true. D. When one triangle is placed on top of the other and their sides are aligned, we will see that one triangle is larger than the other. That's not true. Both the triangles would have the same area and be the same size. E. The two triangles have the same area as each other. That's true. Number 6. Here is an octagon. A. While estimating the area of the octagon, Lynn reasoned that it must be less than 100 square inches. Do you agree? Explain your reasoning. Yes, I agree with Lynn. The area of the square surrounding the octagon is 100 square inches, and the octagon's area would be smaller because the four corners of the square are cut off to form the octagon. B. Find the exact area of the octagon. Show your reasoning. 3 plus 4 plus 3 equals 10, so the base of this square is 10 and the height of this square is 10. To make an octagon, we're going to remove these little corners. It's like removing two triangles from the top and two triangles from the bottom. These triangles form a square with a base of 3 and a height of 3, and 3 times 3 is 9. So each of these squares equals 9 square inches. So it's kind of like we're removing 9 square inches and another 9 square inches. So the original square was 10 by 10, or 100 square inches. When we remove the four corners, it's like removing 18 square inches. And 100 square inches minus 18 square inches equals 82 square inches. The area of the octagon is 82 square inches. Unit 1, Lesson 10. Bases and heights of triangles. Number 1. For each triangle, a base is labeled B. Draw a line segment that shows its corresponding height. Use an index card to help you draw a straight line. Labeled H is the corresponding height at a 90-degree angle compared to the base, B. For the second triangle, here you can see the corresponding height at a 90-degree angle to the base, B. And here for the third triangle, you can see H, the height, that corresponds at a 90-degree angle to the base, B. Number 2. Select all triangles that have an area of 8 square units. Explain how you know. Triangle A has a base of 4 units and a height of 4 units. Triangle B has a base of 4 units and a height of 4 units. Triangle C has a base of 3 units and a height of 4 units. Triangle D has a base of 4 units and a height of 4 units. And triangle E has a base of 8 units and a height of 2 units. The formula for finding the area of a triangle is base times height divided by 2, or half of the base times height. So in this case, in triangle A, it's 4 times 4 divided by 2, or 16 divided by 2. Triangle A has an area of 8 square units. Triangle B also has an area of 8 square units. Triangle C has an area of 6 square units. Triangle D has an area of 8 square units. And triangle E has an area of 8 square units. Triangles A, B, D, and E all have an area of 8 square units. Number 3. Find the area of the triangle. Show your reasoning. If you get stuck, carefully consider which side of the triangle to use as the base. I've used the vertical line on the left side as the base, which is 6 units long. I've used this line at a 90-degree angle compared to the base as the height, which is 4 units long. 6 times 4 is 24, and 24 divided by 2 is 12. The area is 12 square units. Number 4. Can side D be the base for this triangle? If so, which length would be the corresponding height? If not, explain why not. Using side D as the base, I could use G to represent the height because G is at a 90-degree angle compared to side D. Yes, side D could be the base with G as the height. Number 5. Find the area of this shape. Show your reasoning. I'm going to decompose this shape, and here you can see a rectangle that measures 1 by 6, and 1 times 6 is 6 square units. Highlighted in blue, you can see two triangles with a base of 4 and a height of 2. Together, these two triangles have an area of 8 square units. Highlighted in green, you can see two triangles that have a base of 2 and a height of 2. Together, these two smaller triangles have an area of 4 square units. If you add up the area of all these shapes that I decomposed, you get 18 square units. The total area of this shape is 18 square units. Number 6. On the grid, sketch two different parallelograms that have equal area. Label a base and height of each and explain how you know the areas are the same. I kept it simple. I made one square with a base of 4 and a height of 4, and 4 times 4 equals 16 square units. The second parallelogram is a rectangle with a base of 8 and a height of 2, and 8 times 2 is 16 square units. Unit 1, Lesson 11, Polygons. Number 1. Select all the polygons. Figures A and C are polygons. Figure B is not, because of the curved sides. Figure D is not a polygon, because it is not a closed figure. Figure E is not a polygon. It doesn't have straight sides. Figure F is not a polygon, because it's a three-dimensional figure. Number 2. Mark each vertex with a large dot. How many edges and vertices does this polygon have? This polygon has 12 edges and 12 vertices. Number 3. Find the area of this trapezoid. Explain or show your strategy. I will decompose it and rebuild it. Now it's a rectangle with a base of 6 and a height of 3. 6 times 3 equals 18. Count the squares. It has an area of 18 square units. Number 4. Lynn and Andre used different methods to find the area of a regular hexagon with 6 sides. Lynn decomposed the hexagon into 6 identical triangles. Andre decomposed the hexagon into a rectangle and 2 triangles. Find the area of the hexagon using each person's method. Show your reasoning. The dimensions show that the height of the hexagon is 10 and 4/10 of an inch. So the height of the triangles would be half of that. Each of the 6 triangles have a height of 5 and 2/10 inch. To find the area of these triangles, we need to multiply half of the base times the height, or base times height divided by 2. The base is 6, and half of the base would be 3. So half the base times the height would be 3 times 5 and 2/10. 3 times 5 is 15. And 3 times 2/10 is 6/10. The area of each of the triangles would be 15 and 6/10 inches. And since there's 6 of these triangles, we need to multiply 15 and 6/10 times 6. 15 and 6/10 times 6 equals 93 and 6/10. So the area of this hexagon is 93 and 6/10 square inches. Andre decomposed his hexagon to have 2 triangles and a rectangle. Each triangle has a height of 3 inches and a base of 10 4/10 inches. The rectangle has a base of 6 inches and a height of 10 4/10 inches. To figure out the area of the rectangle, we would multiply base times height, or 6 times 10 4/10. To find the area of the triangles, we would multiply base times height divided by 2, or half of base times height. The base is 10 4/10 inches and the height is 3 inches. So 10 4/10 times 3 divided by 2, or half of 10 4/10 times 3. Half of 10 is 5, and 5 times 3 is 15. Half of 4/10 is 2/10, and 2/10 times 3 is 6/10. The area of each of these 2 triangles is 15 6/10 inches. Simply add the area of the 2 triangles and the area of the rectangle, and you'll have the area of the hexagon. The area of the hexagon is 93 6/10 square inches. Number 5. Identify a base and a corresponding height that can be used to find the area of this triangle. Label the base B and the corresponding height H. The base is labeled B and represents 11 units. The height is labeled H and represents 2 units. Now we have to find the area of the triangle and show our reasoning. To find the area of a triangle, we need to multiply the base times the height and divide it by 2, or multiply half the base times the height. 11 times 2 divided by 2 is 11 square units. The area of the triangle is 11 square units. Number 6. On the grid, draw 3 different triangles with an area of 12 square units. Label the base and height of each triangle. The first one has a base of 6 and a height of 4. Half of 6 is 3. 3 times 4 is 12. The second one has a base of 8 and a height of 3. Half of 8 is 4, and 4 times 3 is 12. And the third triangle has a base of 12 and a height of 2. Half of 12 is 6. 6 times 2 is 12. All 3 of these triangles have an area of 12 square units. 6th grade, Unit 1, Lesson 12. What is surface area? Number 1. What is the surface area of this rectangular prism? Well, there's 6 different surface areas: the top, the bottom, the front, the back, the right, and the left. The dimensions for the top and the bottom are exactly the same, 4 by 2, and the dimensions for the front and back are exactly the same, 4 by 4, and the right and the left sides are exactly the same, 2 by 4. 4 times 2 is 8, 4 times 4 is 16, and 2 times 4 is 8. The total of these combined areas is 64 square units. This rectangular prism's surface area is 64 square units. Number 2. Which description can represent the surface area of this trunk? A. The number of square inches that cover the top of the trunk. B. The number of square feet that cover the outside faces of the trunk. C. The number of square inches of the horizontal surface inside the trunk. Or D. The number of cubic feet that can be packed inside the trunk. B. The number of square feet that can cover all the outside faces of the trunk. Number 3. Which figure has a greater surface area? Figure A has a front, a back, a top, a bottom, a right, and a left. The front and the back each have a surface area of 5 square units. The top and the bottom each have a surface area of 3 square units. And the right and the left sides each have a surface area of 3 square units. All combined, figure A has a total surface area of 22 square units. The front and back of figure B have a surface area each of 3 square units. The top and the bottom of figure B each have a surface area of 5 square units, and the right side and the left side of figure B each have a surface area of 3 square units. All combined, figure B also has a surface area of 22 square units. Both figures have the same surface area of 22 square units. Number 4. A rectangular prism is 4 units high, 2 units wide, and 6 units long. What is its surface area in square units? Explain or show your reasoning. Here I've drawn a rectangular prism with those exact measurements. The front has a surface area of 24 square units, and so does the back. The top and the bottom both have a surface area of 12 square units, and the right side and the left side each have a surface area of 8 square units. All combined, the rectangular prism has a total surface area of 88 square units. Number 5. Draw an example of each of the following triangles on the grid. A right triangle with an area of 6 square units. First, I need to think of some dimensions for a rectangle that would equal 12, like 3 by 4. A triangle has half the area of a rectangle, so half of 12 is 6. If I make a triangle with a base of 4 and a height of 3, its area would be 6, because it's half the size of a rectangle. And I made sure it was a right triangle by having the height perpendicular to the base. B. An acute triangle with an area of 6 square units. Again, it's 6 square units. Again, since we're creating a triangle, it's going to have half the area of a rectangle that has an area of 12. I can use 3 by 4, or 2 by 6, or 1 by 12. But I need to make sure I make an acute angle. That's an angle that's smaller than 90 degrees. My acute triangle has a base of 3 and a height of 4, and an area of 6 square units. C. An obtuse triangle with an area of 6 square units. So again, it's a triangle with an area of 6 square units. The only difference is the angle needs to be larger than 90 degrees. The obtuse triangle that I drew has a base of 6 and a height of 2. Number 6. Find the area of triangle MOQ in square units. Show your reasoning. Triangle MOQ is colored blue, and it sits inside a larger rectangle. The large rectangle's base is 10 units in length, and its height is 6 units. Surrounding triangle MOQ are 3 smaller triangles. One of these smaller triangles has an area of 20 square units. The second of these smaller triangles has an area of 15 units. And the smallest of these triangles has an area of 5 square units. Subtract the area of the 3 triangles to find the area of the colored triangle MOQ. The area of the rectangle is 60. Take away 20 square units, take away 15 square units, and take away 5 square units, and what you're left with is the area of triangle MOQ, 20 square units. Number 7. Find the area of this shape. Show your reasoning. First, I'm going to decompose the shape. Doing this formed 3 triangles. The dimensions of the larger triangle on the bottom is 3 by 6.
The area of that triangle is 18 divided by 2, since 3 times 6 is 18. And 18 divided by 2 is 9. The area of this triangle is 9. The two triangles on the top are identical. The height is 2 and the base is 3. 3 times 2 is 6, and half of 6 is 3. The area of each of these smaller triangles on top is 3 units squared. 9 plus 3 is 15, so the total area of this shape is 15 square units. 6th grade, Unit 1, Lesson 13, Polyhedra. Number 1. Select all the polyhedra. Singular is polyhedron, plural is polyhedra. A polyhedron is a three-dimensional figure with faces that are polygonal regions, which are filled in polygons. Each face meets one and only one other face along a complete edge. The points where edges meet are called vertices. Here are 3 examples of polyhedra. Figure A is a polyhedron. Figure B is a polyhedron. And figure D is a polyhedron. The other 2 figures are not polyhedrons. Number 2A. Is this polyhedron a prism, a pyramid, or neither? Explain how you know. It's a prism. It has 2 parallel octagonal bases that are identical in size. B. How many faces, edges, and vertices does it have? First, let's count the faces. 1, 2, 3, 4, 5, 6, 7, 8. And these 2 bases are also considered faces. So 8 plus 2 equals 10. This has a total of 10 faces. Now the edges. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 edges on base 1 and 8 edges on base 2 for a total of 16 edges on the bases. Plus there's another 8 edges that run between each of the 8 faces. So there's a total of 24 edges. Now let's count the vertices. There's a total of 8 vertices on base 1 and a total of 8 vertices on base 2 for a total of 16 vertices altogether. Number 3. Tyler said this net cannot be a net for a square prism because not all the faces are squares. Do you agree with Tyler's statement? Explain your reasoning. I think that Tyler must be thinking of a cube. If all the faces were squares, then this net would form a cube. I disagree. A square prism must have square bases, but may have rectangular faces like these. Number 4. Explain why each of the following triangles has an area of 9 square units. Triangle A is going to be exactly half of its base times height, or half of 6 times 3. 6 times 3 is 18. 18 divided by 2 is 9. The area of triangle A is 9 square units. The area of triangle B is going to be half of its base times its height, or half of 6 times 3. 6 times 3 is 18. 18 divided by 2 is 9. The area of triangle B is 9 square units. The area of triangle C is going to be half of its base times its height, or half of 6 times 3. And 6 times 3 is 18. 18 divided by 2 is 9. The area of triangle C is 9 square units. Number 5. A. A parallelogram has a base of 12 meters and a height of 1 5/10 meters. What is its area? For a parallelogram, you're going to do base times height to find the area. So 12 meters times 1 5/10 meters equals 18 square meters. The area for this parallelogram is 18 square meters. B. A triangle has a base of 16 inches and a height of 1/8 of an inch. What is its area? The area equals half of 16 inches multiplied by 1/8 of an inch, or 1 square inch. The area of this triangle is 1 square inch. C. A parallelogram has an area of 28 square feet and a height of 4 feet. What is its base? So now they've given us the area and the height, so we need to figure out the base. 28 square feet, or the area, divided by 4 feet, or the height, will give us the base. 28 divided by 4 equals 7. The base of this parallelogram is 7 feet in length. D. A triangle has an area of 32 square millimeters and a base of 8 millimeters. What is its height? We can use the area of a parallelogram to help us find the missing height. The area of a triangle is half the area of a parallelogram. Since the area of this triangle is 32 square millimeters, the area of a parallelogram would be 64 square millimeters. The area divided by the base, or 64 divided by 8, equals the missing height. Since 8 multiplied by 8 equals 64, then the missing height must be 8 millimeters. Number 6, find the area of the shaded region. Show or explain your reasoning. The shaded region has a base that measures 6 plus 2 plus 6, or 14 centimeters. The shaded region has a height of 2 centimeters plus 3 centimeters, or 5 centimeters. Since the shaded region has the shape of a triangle with a square taken out of it, I decided to use the formula for finding the area of a triangle, half of base times height, or base times height divided by 2. So 14 times 5, and 14 times 5 is 70. And 70 divided by 2, or half of 70, is 35. Next, we need to remove the square from the shaded region, and the base and the height of that square is 2 centimeters by 2 centimeters. 2 times 2 is 4. So the area of the square is 4. And 35 minus 4 is 31. The area of the shaded region is 31 square centimeters. 6th grade, Unit 1, Lesson 14, Nets and Surface Area. For this lesson, it's important to know what a geometry net is. A geometry net is a flattened out three-dimensional shape like a cube, a prism, or a pyramid. If you were to cut out the net, fold it, and glue it together, you'd see the three-dimensional shape. A three-dimensional shape has 3 dimensions: length, width, and height. Here's an example of a geometry net for a cube. I chose a few different colors at random to help represent the different faces of the cube. The blue section represents the bottom. The red section represents the back. The green section represents the front. The black section represents the top. The purple section represents the right side. And the brown section represents the left side. You can fold these sections up to form a cube. Number 1. Can the following net be assembled into a cube? Explain how you know. Label parts of the net with letters or numbers if it helps your explanation. I labeled the sections the back, the top, the front, the bottom, and the right. but this last section here is in the wrong location to be the left side. It needs to be located on the other side for this net to assemble into a cube. So no, this net cannot be assembled into a cube. Number 2. A. What polyhedron can be assembled from this net? Explain how you know. This net can be assembled to form a triangular prism. A triangular prism. It has two triangular bases and rectangular faces. Find the surface area of this polyhedron. Show your reasoning. To find the surface area of this polyhedron, I'm going to decompose and rearrange. Moving this triangle and joining it with the other triangle forms a rectangle. I'm identifying each of these shapes with their base times their height. 5 times 5, 3 times 5, 4 times 5, and 4 times 3. The areas of these figures are 25 square units, 15 square units, 20 square units, and 12 square units. Add all of their areas up, and the area of the original figure is 72 square units. Number 3. Here are two nets. Mai said that both nets can be assembled into the same triangular prism. Do you agree? Explain or show your reasoning. Here I've labeled the corresponding bases, base 1 and base 2, the front, the right side, and the left side. And it does look like if I folded along the edges, I could make both of them into triangular shaped prisms. I agree, both A and B can be assembled to form a triangular prism. Number 4. Here are two three-dimensional figures. Tell whether each of the following statements describes figure A, figure B, both, or neither. A. This figure is a polyhedron. Both. Both figures A and B are polyhedrons. B. This figure has triangular faces. Figure B has triangular faces and figure A has triangular bases, but bases can be considered faces. So the answer is both. Both figures A and B have triangular faces. C. There are more vertices than edges in this figure. Neither. Neither of these figures have more vertices than they do edges. D. This figure has rectangular faces. Figure A. Figure A has rectangular faces. E. This figure is a pyramid. Figure B. Figure B is a pyramid. F. There is exactly one face that can be the base for this figure. Neither. Both of these figures have more than one face that could be considered the base for the figure. G. The base of this figure is a triangle. Both. Both of these figures have a triangular shaped base. And finally H. This figure has two identical and parallel faces that can be the base. Figure A. Figure A has exactly two identical and parallel faces that can be the base. The answer can't be figure B, because figure B has three identical faces and neither of them are parallel. Number 5. Select all units that can be used for surface area. Explain why the others cannot be used for surface area. Remember, to find the surface area, we need two dimensions, base times height. A, square meters, can be used for surface area. E, square inches, can be used for surface area. and F, square feet, can be used for surface area. Square meters, square inches, and square feet are the result of multiplying the base times the height, which is two-dimensional, and that's exactly what a surface area is, two-dimensional, base and height. B, feet. Feet is a unit of length. It can't be used for surface area because length is just one dimension, and remember it has to be two-dimensional, like length times height. C, centimeters. That's also a unit of length and can't be used for surface area because length is only one dimension. And D, cubic inches. That's a unit of volume and cannot be used for surface area. Volume measures the amount of space that a substance or an object occupies. For example, a container. Volume has three dimensions: base times height times length. Number 6. Find the area of this polygon. Show your reasoning. First, I'm going to decompose and rearrange this shape, moving this triangle to the other side, forming a parallelogram. I'm also going to decompose this top triangle, making two smaller identical triangles, moving one of the triangles to the other triangle, forming a square. Now I have three figures that are really easy to find the area of: a large rectangle with the dimensions of 6 by 3, a square with dimensions of 3 by 3, and a parallelogram with the dimensions of 2 by 3. Now we can find their area by multiplying the base times the height. 6 times 3 is 18, 3 times 3 is 9, and 2 times 3 is 6. The area of each of these shapes can be added together to find the total area of the original polygon. The area is 33 square units. 6th grade, Unit 1, Lesson 15. More nets, more surface area. Number 1. Jada drew a net for a polyhedron and calculated its surface area. A. What polyhedron can be assembled from this net? A triangular prism can be assembled from this net. B. Jada made some mistakes in her area calculation. What were the mistakes? She used an area of 12 centimeters for the triangles instead of 6 centimeters. She forgot to multiply half the base times the height. C. Find the surface area of the polyhedron. Show your reasoning. They provide us with the surface area for each figure: 20 square centimeters plus 16 square centimeters plus 12 square centimeters plus 6 square centimeters plus 6 square centimeters equals a total surface area of 60 square centimeters. Number 2. A cereal box is 8 inches by 2 inches by 12 inches. What is its surface area? Show your reasoning. If you get stuck, consider drawing a sketch of the box or its net and labeling the edges with their measurements. I decided to draw its net. Here's the top and the bottom, the right side and the left side, the front and the back. These dimensions are 2 inches by 12 inches and 8 inches by 12 inches. 8 by 12 is 96, so both the back and the front are 96 square inches. 2 by 12 is 24 inches, so both the right and the left are 24 square inches. And 8 times 2 is 16, so both the top and the bottom are 16 square inches. Add all of those individual surface areas together and you'll have the surface area for the whole figure. The total surface area is 272 square inches. Number 3. 12 cubes are stacked to make this figure. A. What is its surface area? We'll need to find the total surface area for the front, the back, the top, the bottom, the right, and the left. Represented in gold and numbered 1 through 6, you can see 6 square units for the front. So the front would be a total of 6 square units, and the back would also be a total of 6 square units. Representing the top in blue, another 6 square units. Both the top and the bottom are 6 square units. Representing the right side in green, another 6 square units. Both the right side and the left side are 6 square units. 6 square units by 6 different sides equals a total surface area of 36 square units. B. How would the surface area change if the top 2 cubes are removed? Here's a look at the stack after removing the top 2 cubes. From this angle, we can see the top, the front, and the right side. And as you can see, I've counted 15 square units that we can see. But what we can't see is the bottom, the back, and the left side. And those would also total 15. So adding them all up, we would have a total of 30. So after removing the top 2 cubes, the surface area would be reduced to 30 square units. Number 4. Here are 2 polyhedra and their nets. Label all edges in the net with the correct lengths. A. These lengths are 10 units. These lengths are 4 units. And these lengths are 5 units. B. These lengths are 10 units. These lengths are 4 units. And these lengths are 13 units. Number 5. A. What three-dimensional figure can be assembled from the net? A square pyramid can be assembled from this net. B. What is the surface area of the figure? 1 grid square is 1 square unit. For the base, the area would be 4 times 4, or 16 square units. For the outer triangles, the area would be half of 4 times 5, or half of 20. 10 square units per triangle. With 4 triangles, 10 times 4 is 40, or 40 square units. 16 square units plus 40 square units equals 56 square units. The surface area of this net is 56 square units. Sixth grade, Unit 1, Lesson 16, Distinguishing between surface area and volume. Number 1. Match each quantity with an appropriate unit of measurement. A. The surface area of a tissue box. Since they're asking for surface area and not volume or length, I need to look for something that's squared. I would pick 5 square centimeters rather than number 1 square meters because a tissue box isn't large enough to measure in square meters. A tissue box is best represented in centimeters. B. The amount of soil in a planter box. Since they're referring to the amount of soil that would fit inside a planter box, I need to look for a cubic measurement, either cubic inches or cubic feet. Since I don't know the size of the planter box, I don't know if I should select cubic feet or cubic inches, but I notice E, the volume of a fish tank. I also don't know the size of the fish tank. So a planter box and a fish tank can both be large or small. So I can select the same answers for B and E. B can be 3 or 4 cubic inches or cubic feet, and so can E. The volume of a fish tank can be cubic inches or cubic feet. If it were a larger planter box, cubic feet would be a better representation of the amount of soil that could fit inside the planter box. If it were a small planter box, perhaps cubic inches might better represent the amount of soil in a planter box. C. The area of a parking lot. I'm looking for the area of a parking lot, so that's going to be two-dimensional, like length times width or base times height. Since that's two-dimensional, I'm going to be looking for a square measurement, like number 1, square meters. Square meters is better suited for a parking lot because meters are much larger than centimeters. Centimeters are better suited for measuring a tissue box, and meters are better suited for measuring a parking lot. And finally, D, the length of a soccer field. A length is one-dimensional, so we're looking for one type of unit measurement, like yards. Oftentimes, the length of a soccer field or the length of a football field is identified in yards. It would be ridiculous to identify the length of a soccer field in centimeters or the length of a soccer field in miles, but yards make sense. Number 2. Here's a figure built from snap cubes. A. Find the volume of the figure in cubic units. We don't know what kind of units, like we don't know if these are inch cubes or centimeter cubes, for example, but we do know that they're cubes. So we're going to call them unit cubes. The volume of one of these cubes is called 1 cubic unit. So we can tell just by looking that there's 4 cubes. So the answer is going to be 4 cubic units. However, we can multiply the width times the length times the height to get the volume. The width is 1 unit, the length is 1 unit, and the height is 4 units. 1 times 4 equals 4 cubic units. The volume of this figure is 4 cubic units. B. Find the surface area of the figure in square units. The surface area is the total of all the surfaces, base times height. From this angle, we can see a base of 1 square unit, that's represented with the blue top. There is a matching 1 square unit at the bottom. We can't see it from this angle. The green front section is 4 square units. Directly behind the green front is a back that is also 4 square units. The yellow left side is 4 square units. Directly behind the left side is the right side that is also 4 square units. The bases 1 plus 1 plus the sides 4 plus 4 plus 4 plus 4 equals 18. The surface area of this figure is 18 square units. Here's another way to look at it. You have your net with the top base and the bottom base, and you have all your sides. The total of the sides equals 16 square units, plus the top base and the bottom base for a total of 18 square units. And here's even another way to look at it. You have your height of 4, and then you have your 4 sides, so 4 times 4, and you have your 2 bases at 2 times 1. 4 times 4 is 16, 2 times 1 is 2, 16 plus 2 is 18. The total surface area is 18 square units. And even another look, base 1 and base 2, they're each 1 square unit. You have the green front, which is worth 4 square units, the left side yellow, which is worth another 4 square units, the right side, which would be worth another 4 square units, the back side that would be worth another 4 square units. No matter which way you do it, the total surface area of this figure is 18 square units. C. True or false? If we double the number of cubes being stacked, both the volume and the surface area will double. Explain or show how you know. The original volume was 4 square units. Doubling the amount stacked doubled the volume to 8 square units. The statement is true in terms of the volume. The original stack on the left, the doubled stack on the right. The surface area of this section of the original stack is 16 square units. The doubled stack is 16 square units plus 16 square units. The original stack was 16 square units plus the 2 bases. The doubled stack is 16 square units plus 16 square units plus the 2 bases. Notice that the 2 bases didn't double. So the total surface area of the original stack was 18 square units, and the total surface area of the doubled stack is 34 square units. Double 18 is 36, not 34. The statement is false in terms of surface area. Number 3. Lynn said, two figures with the same volume also have the same surface area. A. Which two figures suggest that her statement is true? Figures B and C suggest that her statement is true. Both of these figures have volumes of 6 cubic units, and both of these figures have surface areas of 24 square units. B. Which two figures could show that her statement is not true? Figures A and B show that her statement is not true. They have the same volumes, but different surface areas. The surface area for figure A is 26 square units, and the surface area for figure B is 24 square units. Number 4. Draw a pentagon, a 5-sided polygon, that has an area of 32 square units. Label all relative sides or segments with their measurements and show that the area is 32 square units. When I think of a pentagon, I think of the government building that has 5 equal sides. It's called the Pentagon. For me, this would be pretty difficult to draw with 32 square units, so I'm going to come up with a different shape that has 5 sides. What makes this shape easier for me is it's a square and a triangle. I'm going to decompose this shape into a square and a triangle and figure out the areas. Here's the square with side lengths of 4. The triangle has a base of 4 and a height of 8. I've labeled all the relevant sides or segments with their measurements. The area of the square shape is 16 square units because I multiplied the base times the height, and 4 times 4 is 16. To find the area of the triangle, I'm going to multiply the base times the height, or 4 times 8. 4 times 8 is 32, and since it's a triangle, I need to divide that by 2. Half of 32 is 16. The area of this triangle is 16 square units. Combine the area of these two shapes, and you'll have the entire surface area of the pentagon. 16 plus 16 is 32. The area of the pentagon is 32 square units. Number 5. A. Draw a net for this rectangular prism. Here's the net for the rectangular prism. It has the top, the back, the bottom, the front, the right side, and the left side. B. Find the surface area of the rectangular prism. The surface area of the top is 50 square centimeters, the bottom is 50 square centimeters, the front and the back are 20 square centimeters each, and the right side and the left side are 10 square centimeters each. The total area of all of these sides combined will be the surface area of the rectangular prism. The surface area of the rectangular prism is 160 square centimeters. 6th grade, Unit 1, Lesson 17, Squares and Cubes. Number 1. What is the volume of this cube? There's 4 cubes on top and 4 cubes on the bottom, for a total of 8 cubes. The volume is 8 cubic centimeters. A cube is 3-dimensional. This cube is 2 centimeters tall, 2 centimeters wide, and 2 centimeters long. 2 times 2 times 2 equals 8. The volume of this cube is 8 centimeters to the power of 3, or 8 centimeters cubed. Number 2. Decide if each number on the list is a perfect square. A perfect square is the product of a whole number multiplied by itself. For example, 1 times 1 equals 1. That would be a perfect square. 2 times 2 equals 4. That would be a perfect square, and so forth. A. 16. 4 times 4 equals 16. A. 16 is a perfect square. C. 25. 5 times 5 equals 25. C. 25 is a perfect square. D. 100. 10 times 10 equals 100. D. 100 is a perfect square. F. 144. 12 times 12 equals 144. F. 144 is a perfect square. G. 225. 15 times 15 is 225. G. 225 is a perfect square. H. 10,000. 100 times 100 equals 10,000. H. 10,000 is a perfect square. B. 20 is not a perfect square because no whole number times itself equals 20. And E. 125 is also not a perfect square because no whole number times itself equals 125. B. Write a sentence that explains your reasoning. Multiply a whole number by itself to find a perfect square. Here's a few examples of perfect squares. 1 times 1. 1 times 1 equals 1, so that's a perfect square. 2 times 2. 2 times 2 equals 4, so 4 is a perfect square. 3 times 3 equals 9. 9 is a perfect square. 4 times 4 equals 16, so 16 is a perfect square. 20 is not a perfect square, and here's some examples why 20 is not a perfect square. 1 times 20 does not form a square, 2 times 10 does not form a perfect square, and 4 times 5 does not form a perfect square. This decimal is obviously not a whole number, and this decimal times itself equals 20. That's proof that 20 is not a perfect square. Here's a close look at the side lengths of this square. It's not a whole number, it's a decimal. Since the side lengths are not whole numbers, it does not form a perfect square. Number 3. A. Decide if each number on the list is a perfect cube. Cubes are three-dimensional. They have a height, a width, and a length. A height of 1, a length of 1, and a width of 1 would be 1 times 1 times 1, and that equals 1 perfect cube. 1 cubic unit, or 1 unit to the third power. 2 times 2 times 2 equals 8, so C, 8, would be a perfect cube. This cube is 2 units wide, 2 units long, and 2 units tall. 2 times 2 times 2 equals 8 cubic units. 3 times 3 times 3 equals 27. So 27 is a perfect cube. 4 times 4 times 4 equals 64. So 64 is also a perfect cube. 5 times 5 times 5 equals 125. So 125 is also a perfect cube. 3, 9, and 100 are not perfect cubes because there's no whole number that can be multiplied times itself that would have the result of either 3, 9, or 100. B. Explain what a perfect cube is. Multiply a whole number by itself 3 times to find a perfect cube. Number 4. A. A square has a side length of 4 centimeters. What is its area? Here's an illustration of a square that has side lengths of 4 centimeters. 4 centimeters times 4 centimeters equals 16 square centimeters. B. The area of a square is 49 meters squared. What is its side length? Here's an illustration of 49 meters squared. If you look across the top, you can see that the top side length is 7 meters. Since it's a square, all the side lengths will be 7 meters. C. A cube has edge length 3 inches. What is its volume? Here's an illustration of a cube that has edge length 3 inches. 3 times 3 times 3 equals 27. The volume of this cube is 27 cubic inches, or 27 inches cubed, which is the same as 27 inches to the third power. Number 5. Prism A and Prism B are rectangular prisms. Prism A is 3 inches by 2 inches by 1 inch. Prism B is 1 inch by 1 inch by 6 inches. Select all statements that are true about the two prisms. Prism A is 3 by 2 by 1. So the volume of Prism A is 3 times 2 times 1, which is 6. The volume of figure A is 6 cubic inches. The area of Prism A is 22 square inches. Figure B is 1 by 1 by 6, or 1 times 1 times 6. So the volume of figure B is 6 cubic inches. The area of figure B is 26 square inches. Prism A has a volume of 6 inches cubed and an area of 21 inches squared. Prism B has a volume of 6 inches cubed and an area of 26 inches squared. A. They have the same volume. Well, their volume are both 6 inches cubed, so that's true. They have the same volume. B. They have the same number of faces. They have a front, a back, a top, a bottom, a left, and a right. That's 6 faces. So that's true. They both have the same number of faces. C. More inch cubes can be packed into Prism A than into Prism B. That's not true because they have the same volume. The same number of cubes could be packed into Prism A as into Prism B. D. The two prisms have the same surface area. That's not true because Prism A has a surface area of 22 inches squared and Prism B has a surface area of 26 inches squared. E. The surface area of Prism B is greater than that of Prism A. The surface area of Prism B is 26 inches squared, which is larger or greater than the surface area for Prism A, which is only 22 inches squared. Number 6. A. What polyhedron can be assembled from this net? A triangular prism. B. What information would you need to find its surface area? Be specific and label the diagram as needed. You can see I've labeled the bottom, the front, the back, the right side, and the left side. One important piece of information you'd need would be the height of the triangle and the length of the base of the triangle. You'd also need to know the height and the base of the 3 other faces that make up this polyhedron. Number 7. Find the surface area of this triangular prism. All measurements are in meters. The height of the triangular faces are 8/10 of a meter, and the length of the bases of the triangular faces are 1 2/10 meters. The area would be half of 8/10 times 1 2/10, or 48 hundredths square meters. Since 1 2/10 times 1 equals 1 2/10, the area of each of these faces is 1 2/10. And finally, the last face. That's 1 2/10 times 1 2/10, or 1 44 hundredths. We can find the total surface area of this triangular prism by adding up all the areas of the faces. The surface area is 4 8/10 square meters. 6th grade, Unit 1, Lesson 18, Surface Area of a Cube. Number 1. A. What is the volume of a cube with edge length 8 inches? The volume is three-dimensional, the width, the height, and the length. So the volume is going to be 8 times 8 times 8. The volume is 512 cubic inches, or 512 inches cubed. Another way to say it is 512 inches to the third power. B. What is the volume of a cube with edge length 1/3 centimeter? The width times the height times the length will equal the volume. So 1/3 times 1/3 times 1/3. The volume is 1/27 cubic centimeters, or 1/27 centimeters to the third power, or 1/27 centimeters cubed. C. A cube has a volume of 8 feet cubed. What is its edge length? The width times the length times the height equals 8 feet cubed. The edge times the edge times the edge equals 8 feet cubed. This cube is 2 feet wide, 2 feet long, and 2 feet high. 2 times 2 times 2 equals 8 feet cubed. The missing edge length is 2 feet. Number 2. A. What three-dimensional figure can be assembled from this net? The three-dimensional figure that can be assembled from this net is a cube. B. If each square has a side length of 61 centimeters, write an expression for the surface area and another for the volume of the figure. In thinking about the expression that I'm going to write, I have to remember that there's 6 faces to this net. Each face, or each square, will have the dimensions 61 centimeters for its side length. Since 61 times 61 is also 61 to the second power, the area of this square, or the area of each square, would be 61 to the second power squared centimeters. Remember, 61 squared, or 61 to the second power, is the same thing as 61 times 61. And 61 times 61, or 61 to the second power, is 3,721. So the area of each square could also be 3,721 square centimeters. Here's the expression that I chose to write that represents the surface area of the figure. 6 times 61 to the second power squared centimeters. Another expression could be 6 times 3,721 squared centimeters. And 6 times 3,721 squared centimeters equals 22,326 squared centimeters. All three of these expressions could represent the surface area of the net. And now we need to write an expression that represents the volume of the figure. Since that net forms a cube, I'll start by drawing a cube. 61 times 61 times 61, or width times height times length. The expression that I chose to represent the volume of the figure is 61 centimeters cubed. Number 3. A. Draw a net for a cube with edge length x centimeters. Here's the net for the cube with edge length x centimeters. The x is a variable that represents an unknown value. B. What is the surface area of this cube? That's also like asking, what is the surface area of this net? Each of the 6 squares in the net have a side length of x centimeters, and x times x equals x squared. So the area of each square would be x squared squared centimeters, or x to the second power squared centimeters. Since there's 6 squares, all with the same area, the surface area of the cube, or the surface area of the net, will be 6 times x to the second power squared centimeters. C. What is the volume of this cube? Width times length times height equals volume, and in this case it's x centimeters times x centimeters times x centimeters equals the volume. And x times x times x is x cubic centimeters, or x centimeters to the third power. Number 4. Here is a net for a rectangular prism that was not drawn accurately. A. Explain what is wrong with the net. When the shape is folded, the 2 small squares are not the right size to close the three-dimensional figure. After it's folded up, you can see that there's a gap like the example that I left on the right. That white section represents the gap. B. Draw a net that can be assembled into a rectangular prism. There's quite a few different ways you can do it, but this is the way that I selected. And as you can see, I enlarged that section that was too short before, so now it would enclose the entire figure. C. Create another net for the same prism. I'm just going to make some adjustments to this existing net. First, I'm going to get rid of these 2 small squares. Then I'm going to add the correct length sides. Number 5. State whether each figure is a polyhedron. Explain how you know. Figure A is not a polyhedron because it has curved surfaces. It also has faces that are not polygons. Figure B is a polyhedron because it is composed of polygons. Each side of every polygon joins a side of another polygon. Number 6. Here is Elena's work for finding the surface area of a rectangular prism that is 1 foot by 1 foot by 2 feet. She concluded that the surface area of the prism is 296 square feet. Do you agree with her conclusion? Explain your reasoning. I disagree. Elena calculated the area of the top and bottom faces in square inches, but she calculated the side faces in square feet. To stay consistent with her measurements, she could change the 12 inches to 1 foot. Now the surface area for the top and bottom would be calculated by multiplying 2 times 1 times 1, and that would equal 2 times 1, which is 2. The area of the 4 side faces, which is 8, and the area of the top and bottom faces, which is 2, would combine for a total surface area of 10 square feet.